Here we are, 6.7b, page number 556. This is under C, bottom of the page, equality for complex numbers. All right, so we've got a formula. It seems like whenever they give properties and they use all these letters, sometimes it gets a little bit confusing, but let's see if we can kind of explain what this is. All right, so this says that if we have a number plus a number times I. So this is called the real part, and this is called the imaginary part because it's times I. So if the real parts are equal to each other, and the imaginary parts are equal to each other, and let's just look at the real number part of the imaginary part, then this is a true statement. So if we are given examples with regular numbers in it, and we have something like 3x plus 4i, and that equals 12 minus 8yi. What that means is if I've got that and I want to solve for x and y, what do? I take the real part and make those equal, and that helps me to find the x. And if I make these equal to each other, it gets me to find the y. So all I need is the 4 and the y, 8y. I don't put the I in there because I'm just comparing the numbers here, or the numbers and variables and not the imaginary part. So let's say divide by -8. So y equals -4 over 8, which that reduces to -1/2. Okay, so let's look at a few of them following that instruction there. So if we have 4x minus 3 plus 7i, and I say that equals 5 plus 2y minus 1i, we're going to say that the 4x minus 3 equals 5. And we're going to say 7 equals 2y minus 1. So just the 7 and just the 2y minus 1. So then I go ahead and solve. And this one here, we add 1 to both sides. Divide by 2. So y equals 4 and x equals 2. And that lets me solve for the variable. And that's when I've got them equal to each other. So when there's equal signs involved, that's what I do for that. All right, so part D, addition and subtraction of complex numbers. And the instructions say that if I have a plus bi, and I add a c plus di, that gives me the real part added together plus the imaginary part added together, and this time I put the I on there. So the same is true if we have subtraction. A plus bi minus c plus di. That's going to give me a minus c plus b minus d. Okay, so pretty much the exact same thing, except we put subtraction there. So let's look at example 10. We have a 3 plus 4i, and we're going to add 7 minus 6i. So that gives me the real part, like that, and the imaginary part. So we just take the 4 and the 6. 4 minus 6. And then we put the I there. So we have 10 plus negative 2i, or we just have 10 minus 2i when we do that. Okay, so continue on. 7 plus 3i, and let's do a subtraction. 5 plus 6i, that's going to be my 7 minus 5 plus 3 minus 6i. So let's bring this down just to remind you of what happens here. Because of this minus sign, we have a minus here and a minus here, but the sign between the two is still a plus, just like it's still a plus there. Very important to remember. The plus sign is there. You're just subtracting the real part and the imaginary part. So that takes us to what we have here. So this is going to be 2 plus 3 minus 6 is negative 3i. So 2 minus 3i. Okay, this is example 12, bottom of page 557. 5 minus 2i minus 9 minus 4i. Again, it doesn't matter if that minus sign is there or not. So we take our real part. Then we have a plus. And then we have negative 2 plus 4i. Now, why is this plus? Because a negative and a negative. So really, what is happening, let me see if I can get us back up here to this other one, the one we did right before this. Okay, so we have a 7 minus 5, and we have a 3 minus 6. So it's as if we distribute this negative. So it's kind of like doing this. Okay, so now we have 7 minus 5, 7 minus 5, 3 minus 6, and that plus sign is right there. Okay, so let's look at what we've got on this next one. So we've got this negative. We're gonna take this negative and distribute it. So I'm gonna make this a plus sign, this a negative, and that a plus sign. So now we have 5 minus 9, negative 2 plus 4. So when you see the minus sign in here, like what we had here, change it to a plus and change the signs of what are inside the parenthesis here. And then it makes it real easy to jump to that part. So this gives me negative 4 plus negative 2 plus 2 is, or negative 2 plus 4 is 2. And then we have our I. So that is key. Whenever this is a subtraction, change it to plus and change the sign of what's in here, and everything will work out for you better there. So basically what I'm saying is this should always be a plus sign. So when there's a minus, change it. When we have a plus like up here, you don't change anything. You just do what you need to do, okay? But when it's a minus, you change to the minus. You change this to a plus and then change the sign of everything in here and everything works. So anyway, something to keep track of. I'm trying to talk and move stuff around at the same time. Sorry for that. All right, multiplication. Multiplication is always so much easier. 3 minus 4i, 2 plus 5i. Okay, so this one here, all we're going to do is FOIL. So we're going to do first. We're going to do outside, inside, and last. Okay, not too bad. We're going to combine these two. And one of the things that we know from earlier lessons is I squared always equals -1. Two negatives give me a positive. Add this and this. And remember that the number always comes first, and then the imaginary part of the complex part comes second. So the product of 3 minus 4 and 2 plus 5i is 26 plus 7i. Okay, so just do the FOIL method on that one, and it works out just fine. Let's look at 2i times 4 minus 6i. I'm going to distribute that, and there. And I squared equals -1. So 8i plus 12, but we're going to write it in the correct format. So we're just going to switch those around. Okay, keep going. Example number 15. 3 plus 5i quantity squared. So let's do FOIL method again. You can do it another way, but the FOIL method is just the easiest one to remember. So let's do first outside, inside, and last. So treat the imaginary part, the I, as a variable, and then you'll do fine. So like when you multiply this times this, you get 15i. When you multiply this times this, you get 25i squared. So that gives me 9 plus 30i plus 25i squared is -1. So 9 plus 30i minus 25. Combine that, and I get 30i minus 16, or not equal, minus 16. I have to switch those around. And that's what I get for an answer. Don't forget to switch them around so that the real part is first. Bringing me to example 16, 2 minus 3i times 2 plus 3i. Now this is the answer to the difference of two squares. So if I square the first term and square the second term and put a minus sign between them, I don't have to do the FOIL method. So 4 minus 9i squared, and again, I squared is -1. So 4 minus 9 times -1, 4 plus 9 equals 13. Now, if you were to do the FOIL method, you'd still get the same answer of 13. So whichever way works best for you. I know the book wants you to practice the difference of two squares, but sometimes it's just hard to recognize. It's really hard to see. Top of page 559. And let's see, I've got 1, 2, I just have 2 more problems to go. Maybe I can do it. And now I'm going to have to go to another video because they're a little bit more time consuming.